Hi everyone, this is my talk on how to create scripting tools for designers, preferably without them having to use Blueprint directly. So first things first, who am I? My name's Brad, and I'm a senior game programmer working at Deep Silver Dambuster Studios in Nottingham. We're currently working on Dead Island 2. You might have seen our trailer at Gamescom this year. So first things first, the problem statement, what we're here to solve. So we want it so that designers can focus on creativity. They shouldn't have to come and ask engineers constantly, how should I do this? What do you want me to do? Is this going to work? Is this ready for ship? And the issues we're specifically trying to target with this is things like copy-pasted solutions everywhere. Most of you probably experience this, where designers pass solutions around and change them ever so slightly. Making it easier to change your exposed interfaces. If you've made a Blueprint callable function and you want to change a parameter, change the name. If it's in Blueprints, it's fixable. If it's in level Blueprints, it's a massive pain to go and find, and you very often end up with cook errors that you have to spend days chasing. Different designers having different methods. This is similar to the previous one, where different designers do the same solution or a very similar solution, but in very different ways, and debugging that becomes a massive problem. And making it so designers don't have to understand technical concepts too far. They're not technical people usually, so it usually takes you a lot of time to explain these things to them. And the classic one, the spaghetti blueprint, which everyone wants to avoid. This isn't taken from our game, by the way. This is online. We avoided this issue. I had to specifically go and find one. So starting with what we previously had before I started any of my scripting things. So we had a concept called utils. So this was a Blueprint interface passing messaging system where you'd pass a single named function to another Blueprint and it would interpret it. So you'd say trigger, pass it to a barrel, and the barrel would interpret what triggered meant. And we had a lot of what we called mission system focused scripting. So our mission graph was massive. Instead of it being player go to door, open door, you'd have lots of spawn things in there, lots of sound effects, all sorts, and it was just a spaghetti nightmare to work out. If you want more detail on this, Michelle Chapman's talk from Unreal Fest 2019 is still on YouTube and still really good. So I'll give you more background specifically. So I'll go through some of the prereqs that I had before actually starting this. So the first thing is obviously the mission system. This existed before I started my scripting journey. So it's quite simple. Bunch of nodes. Each one represents an objective. Have some logic nodes for things that are a bit more complicated than linear flows. Types of objectives, such as a reach or an interact. You've all probably got something very similar to this. Another one we had was the knowledge base. I asked someone at Dambuster for a description of how the knowledge base works, concisely. This is what I got. So we'll skip that. What it actually is, in nice picture form, is a named fact, a fact which can be dynamically generated, a bit like a variable, has a type, has a value, and then you can ask questions of it. So in this case, I could say, am I Brad? Yes, I am. And I can do something in response to that. And then there's different types. So I say, are we at Unreal Fest 2022? Yes, we are. And then you could say, am I Brad? Am I at Unreal 22 right now? Yes, I am. So it allows you to store data and pass it around and query things without having to directly know who the target is. So now that that's all the prereqs out of the way, so I'll just go through the contents of what I'm going to talk about while we're here. So empowering designers safely. What do I mean by safely? Events versus states, two different types of philosophies, and when to use which, and how to combine the two. Persistence versus inference. I'm going to explain more about what that is when we get to it. Some challenges and concessions. No solution is perfect, and I'm going to acknowledge some of the problems we had, some of the ways we overcame them, and some of the things we still have. And depending on how much time I've got, a couple of the coding tricks I used to make this easier, which should be quite interesting if we have time for that. So the main thing then, empowering designers safely. What do I mean by safely? So the ability to abstract technical concepts. So we don't want designers to have to spend ages looking things up, going, oh, how many logic nodes do I need? How do I use a for loop properly? They shouldn't have to worry about those kind of things. They should just be able to get stuck in and make it work. Promoting centralization. So we don't want repeated solutions in slightly different ways. We want the solution in one place that we know works, and if there's a bug in it, we fix it once, and it fixes across the entire game. Better balance of responsibility. What is an engineer's job? What's a designer's job? What crossover is there? How do you know who does what? Forcing consistency in terminology. So again, with the centralization idea, quite often you have people using similar terms for the same concept, and that can be quite a problem. if we, as engineers, take over the entire functionality, we can take over the terminology, and you'll hear some of the cool names we've come up with as we get a bit later into the talk. Reduce wasted work. So designers quite often think very, very narrow. They're doing one setup, and they think, how do I make this exact one setup work? And you can end up with a lot of wasted work. A lot of each designer's told a door to open or close, and you go through the entire flow, and you've told the door to change 10 times before you've even hit the begin play window. All wasted work. So take that responsibility away. Performance, the big one everyone cares about, so we don't want them to just make something work in the least performant way. We'll just take charge of that. And one really good one, debuggability. If we take control, we can inject all the debugging, and we can teach them how to use the debugging, and they can learn the systems, but without knowing the technical background. So, got a little Brad, and this is our paper design mission. So a designer's come to us, and they've said, I want to have the player go up to a door, they press some kind of switch, door opens, TNT goes bang in the background, they progress. That's basically an encapsulation of an objective or two. They progress further through the level, they find some kind of area, and there's some music playing to create some ambience. So that's what your designer's told you, that's what they want, start to finish. Not really from our game, just a very simple example. So the first big hurdle of that is the switch door communication. So you want it so that the player can press this switch, the door opens in response. So there's a couple of obvious ways we could do this. We could have the door pull the switch, repeatedly ask it the same question, have you been pressed recently? We could pass a listener interface and say, call me back when you're ready, or we could use Unreal's delegate system. So all three of these would work, and they all, broadly speaking, look a bit like this, where the switch has to, in some way, tell the door it's pressed, and the door, in some roundabout way, has to say, inform me when something changes. In isolation, this can be fine, but once you start introducing more scripting elements, such as, let's say, there's a trigger shape that wants to open the door. Let's say it's not a door anymore, it's become a barrel. You want the trigger to tell the barrel. You want a lookout target to do the barrel instead. Instead of it being a barrel, you want it to be a music player. Instead of a lookout target, you want it to be a door. When the door opens, music plays. When the door opens, it sets the switch to on or off. So you end up with a lot of very similar messages being passed around and having to do a lot of interfaces or a lot of delegates. And you might have noticed that is the inverse of the problem, so we've just created a back and forth messaging system. So if we put it back to the original problem, the solution I came up with was to remove the door needing to know about the switch at all through any means, and remove the switch having to directly communicate with the door, and go through a scripting layer in the middle. So neither side has to know about the other directly. And this manifested as what we've dubbed the game event. So essentially, this is a designer-facing delegate. It's something the designer can set. We make a pact, and we say, once someone presses a switch, we will fire this thing for you, do what you want with it. And we followed a similar pattern to the multicast delegate. So we have one event, and it can fire as many responses as the designer wants it to fire. And we kept the interface as simple as possible. So one function, one parameter, you just pass the most relevant actor, and that's all you get. And that's what the delegate interface looks like. So we tried to keep parity to make it as easy to understand as possible. So going back to the example, this would manifest as the switch would have a game event on it saying, I will fire this thing when a switch is pressed, similar to a delegate. And the scripting layer would be a specific type of response that knows how to open a door. So we've kept all the information in the scripting layer. We've passed a message in to say, I want you to execute a response, and the response knows how to sort itself out. So looking at this in actual Unreal then, so really, really simple, just an exposed UObject, instantiate it, make a list of responses, which are also instantiated, and then just provide whatever information you need. And that's kind of it. That's the whole game event, and you can make as many as you want, place them as wherever you want. One bonus piece is this is something we had called a blueprint link. Again, this is covered in Michelle's talk. And it's basically something I'd really recommend is it connects actors together that communicate. You draw it as a visualization, and it makes it easier to navigate in the editor. So a little bit more about the game event then. So we decided to keep the interface as simple as possible. It's literally two functions. It's a setup function, which just allows you to put some very basic pieces of information in. Usually the world, because UObjects, you can't get the world unless you've specifically passed it in through something or given it another accessor. And execute. So the idea is you call setup once and execute as many times as you possibly need, and it should do the same thing. A few rules we put in place. So It should be stateless, so we tell people who make these game events you shouldn't have to store anything because it should be the same response every single time they call it, making it consistently callable. And we went with the principle of KISS, keep it small and simple. So if we go back to the paper design, we'll see where we get to add some game events. So first proper place would be the switch, right, naturally. So the switch is the first thing the player does. So we say when the switch is pressed, we want to open the door and explode the TNT. So nice and simple, would take a designer 20 seconds to set that up. And the music playing, we could do this with 2 different game events. One when the player enters, the music starts. One when the player enters, the music stops. So from there, we can expand. Having an on-off event is usually kind of a red flag. So we moved on and using the anim notifiers as a sort of base, where we took the idea of having an anim notify and anim notify state, we've had a game event state. So this is the exact same pattern, one game event, lots of responses, and its entire purpose is to scope arbitrary behavior. So it has a start and a stop, and you make the agreement that you'll always clean up. So you say, while something's happening, I'm going to make something else happen. So whilst the player is stood here, I'm going to turn some music on, for example. And we went really hard on this, and we said there is no place in our game where a game event state should ever fail to shut down, and I ended up calling it the begin destroy guarantee. So if you fail to clean up one of these in our game, it is a hard assert. You bring the whole game down. So we know for certain there is no place in the game where a state is ever left on. So looking at it again in Unreal, the way we would have done this with game events first is you'd have onShape populated, open a door, point at the door, onShape emptied, close the door, point at the door. That's using pure game events. If we swapped it to a game event state, suddenly it becomes a little bit easier to set up and a little bit easier to follow. It's just while something's inside the shape, open the door. And there's a bonus in there that we've only pointed at the door once. We've lowered the error threshold, half as much data to set up, and less chance of data going out of sync. So going back to the paper design again. So nothing really to change here yet. It's still a one-shot event. It's still press the switch, move on. There's no states being done. Same with the barrel exploding. The only place where there's actually a state will be in the shape. So instead of doing a start and a stop event, we just change it to a whilst event. So cut it in half, kept it simple, much less error prone. So taking those forwards, I mentioned event versus state earlier on. So for me, an event is on or when something happens. You say, something has happened, therefore I will fire something as a response, as an event. It's used in a lot of projects, including ours, but it can result in a lot of what I call dot-to-dot setups, where an event A triggers B, triggers C, triggers D, and you can end up with a massive spaghetti of these things where suddenly one of the letters fails, and you've got to backtrace all these different events. And for us, this is the game event, which is why we've sort of shrunk down the usage of them to very specific instances. And then state-based systems, so this is the other side. So this is, whilst something is happening, I want something else to happen, I will set a state. These can be a lot less error-prone because there's less things to set, and you know it's scoped correctly automatically. You don't have to worry about shutting things down. And this manifests as the game event state for us. But what you might have noticed is that has both the word event and state in. That's not an error. A game event state is not a true state. It is a state that executes at event time. So you have to start the state and then maintain it. So how do we get to a proper state? So this was one of the biggest wins for us as a studio, was tying together the knowledge base and the mission system, the 2 pieces I said at the start. So we ended up coming up with the concept of what we called a knowledge base expression builder, affectionately known as the KBEB, and that's your terminology consistency right there. This ended up as, in the editor, we would expose, again, another instance view object of information, in this case an objective range with a start and an end, and we would boil it down to a piece of text that the knowledge base would understand. And what this means is we can infer a specific state based on where the mission system is. And we did all this at editor time, so at runtime, it's just a piece of text. There's no hard references outside of editor time, which makes it a lot cheaper. So running the simulation again. So, first thing you'd want is you'd say, once the switch has been pressed, logically the door should be open. Regardless of whether the event fires, that is the state we've asked for. Because of that, we don't actually need the game event anymore, because when the mission system advances, knowing that the switch has been pressed, we don't actually need to send an event. The state of the game will just update itself. While we're here, we could do the exact inverse for the switch. So once you've pressed the switch, it knows it has been pressed. You don't have to actually store anything. It lets you, it lets you work out what's going to happen. And in this case, if a rollback happens, so the player's died, or for some reason you've had to roll back to a checkpoint, the mission system's gone backwards to the correct state, all the KBEBs have reinitialized themselves, and all the state's been put back. The door's reclosed, the switch is back in its off position. You haven't had to set any events going to put these things back into the right state. Important bit here is, though, that the TNT has reappeared, and nothing's made that happen. So we'll cover that in the next bit. One other thing we could KBEB while we're here is the shape being active. So you want as few things active in your game as possible. So by using KBEBs, you can specifically say this shape is only active between these two objectives and never again in the game. And therefore, after that, it's just an empty actor, really, not doing anything, not costing you that much. To get the TNT to reappear, we came up with a concept called the conditional actor. So this is an actor spawner that puts something in the world when it's required. So it takes an actor class to spawn, which in this case just do a barrel. And we found out you can actually put an instanced actor onto another actor, and it lets all the properties be editable. Then when you do construction through the world spawn actor function, you can pass in a template, and that will generate an actor that is an exact copy of that actor. So this level design put down a barrel and then suddenly go, oh, I want it pink, and it takes 6 seconds to explode. They could do that without generating a brand new blueprint. We let them spawn a preview actor so that they could place it in the world and see exactly how it looks. But importantly, it uses the knowledge base again. So this actor will only be present, only be spawned when it actually needs to be, which means you can change the level dynamically as you progress through it. So in this case, all we do is we delete the TNT entirely, make a conditional actor, set it to only spawn when the switch isn't there, and blow it up with a game event still. So the game event has done the event of the explosion, but the conditional actor is handling the state of whether it should or shouldn't be there. Okay, so persistence. So we've made the mission work, broadly speaking, but what about coming back in later on? So most of you are probably familiar with persistence, won't go too far into it, but it's basically saving an object state or some piece of data to disk and then being able to use it later when you reload. Most games have it. But it can be really slow and result in a lot of stalls, especially on previous gen hardware. If you're saving too much, you can end up with this just huge stall that you can't solve. But even in our game, we do still use persistence. I'm not going to tell you we don't use persistence at all. We still use it for progression, player state, things like that. So how do we actually get the game into the correct state then? So we use what we've dubbed inference. So this is the ability to infer the state based on what you persisted. So you save the minimum amount of data, which in this case is the state of the mission, the whole mission state, sorry. And from there, you use all those KBEBs I was talking about earlier, and you infer the state. You say, I know that door over there is open because the mission system says I've gone past objective 6. So therefore, the player must have walked through that door at some point. Door is open. We've saved nothing. This becomes rollback safe because we're not actually persisting it. We don't have to query each object and say, ooh, should you be in this state now? It's just the state has changed because the mission system has gone backwards. Therefore, we reclose the door. This was huge during testing, so we don't give QA any save games or anything. We just have a list of objectives they can start from. They load into the game, and the whole game world just builds itself. It just goes, right, you're at objective 8, mission 2, right, this is how the game should be. And it also helps us with networking because we don't have to throw as much persisted state across the network when a client joins a host midway through the game. we just throw the mission system across and go, this is the state of the mission system, mirror that, and then set up your world to match. So how do we actually use inference in this example? So the things we can infer is the door open or closed right now? Which is based on the state of the switch. Has the switch been pressed or not pressed? Should the TNT be here right now? Which is also based on the switch. And then is the switch in its up position or its down position? And that is based on the mission system saying what state it's in. So by that logic, the switch doesn't matter. The switch completely doesn't matter to the actual state of your objects. All that matters is that the mission system knows that the switch must have been pressed at some point. Therefore, the door and the TNT know nothing about the switch. They're all k-bebbed appropriately. So one other piece of tech, this doesn't come up in the example, but this was sort of our biggest scripting endeavor. So this became the combination of every other piece of tech, or nearly every other piece of tech you've seen up to now. And it formed the basis of our complex scripting toolage. So it's going to look like a lot, but essentially, we gave level design the ability to run a script of logic, a little bit like a level blueprint, but very scoped, very controlled, and it was all built out of little modular blocks. So it has the knowledge base in here, it has a couple of game events in here, so stage started, stage ended, while stage active, so that gives them the power to say, on a condition, fire something, change the world state. We give them different types of modular blocks, which means we can append things like spawning, specific target spawning, wave spawning. They can do all this just with specific types of data. And we also modularize the exit condition, so they can decide how long this thing goes for. So because we went with this approach, it means that we can very easily add new derivatives of these objects. So when a designer says, oh, I need to make this specific kind of mission, everything's 2 to 3 functions and a small U object. You can turn it around in half a day. A few things we learned as we went along with this. We ended up coming up with the idea that these can never persist or maintain state. So they're quite complex scripting tools. There's a lot going on. We just set the hard rule. You run one start to finish unless you early out for a rollback. Other than that you can't maintain it. And this forced design to make it almost like objective-based. Like they couldn't make them too long. It kept them quite short, quite controlled. The big question for us was, is this actually preferable to level blueprint? It mostly is. It becomes dependent on the programmer to be able to turn around the tools that the designer needs, but it has all the advantages of things not getting lost in level blueprints and not having to expose things to designers or even to blueprint that you don't want to expose. The one big concession we found using this was it can actually be too powerful. So once your designers get really familiar with the tool, we had a lot of what we called build your own objective. So we'd have, like, let's say, a kill objective where you kill one target, and they go, yeah, but I want it to do this thing. And instead of asking, they would go off and go, oh, the scripted sequence provides absolutely everything I need. I'll use that. Then you end up with all the bugs, which are like, oh, but there isn't the compass color. The sound effects are wrong because it doesn't have the functionality that they didn't realize wasn't actually there. So yeah, a word of warning. If you're doing something this big, try to sort of instill it in designers early that they have to use it in a very controlled manner. So some of the challenges and concessions that we faced along the way with this, one of the biggest ones for us was communication. So we had a lot of times where designers would reach out to random engineers and say, oh, I've got a problem with this door, can you help me? Now, they don't necessarily know which engineer is the most relevant, so it was a crapshoot, basically. They would choose at random, and then the engineer would have to either try to answer or try to guess who they thought it was, and you'd end up with this, like, passing around of messages. So we ended up coming up with a centralized solution where in our chat server, we have a single place and we say designers shouldn't come and ask questions of engineers directly. They should always go through a public channel. All engineers that are relevant to questions they're likely to ask will be in there and will jump forward to answer the question. So this solved a lot for us and saved a lot of time. We didn't have to repeatedly answer the same questions. We didn't have to ask each other questions. Everything was in one place, everybody could see it was public, and as a bonus, it acted as a bit of an archive. So let's say somebody's on holiday, somebody's off ill, whatever, and a similar question comes up, you can go back through the archive, use the answer they've previously given and gone, oh, last time such and such said this, probably pretty similar to that, could you try doing that? The inverse of that communication problem was when things were ready. So we all have like bug tracking software or work tracking software, but not many people use it to its full potential, including us. So we had a lot of designers coming going, oh, is such and such a thing ready yet? Or, oh, is this ready? Can I use it yet? And quite often you want to do like incremental changes. You don't want to commit your entire thing in one go. You want to safely bank things, make sure it compiles, make sure it cooks. So yeah, to solve this, we ended up coming up with something we called DIDs. So this was a single chat channel, and only engineers can post in it, and we basically announce as soon as a feature is ready to use. We give all the information up front in one shot, and all designers get to read it. It lets you explain exactly what your tech's going to be used for, why it's going to be used, and importantly, it allows you to front-load usage requirements. This saved us so much time, because instead of having to program really complicated requirements where we go, well, if the designer presses this button, then this button, then this button, it'll break, you just write a paragraph saying, don't do that. Just don't do it. And then your code base isn't as heavy. There's an example one, not going to get you to read through the whole thing, but broadly speaking, it's the title of what it is, a description of how to use it, a little bit of debugging information, the front-loaded usage requirements, a link to some documentation, and then telling the designer where to go if they want to ask questions. They don't ask questions in that channel, they come to the other channel and say, oh, can you help me with this? Similar to R&Q, acts as a reference archive, so it acts as like soft documentation, really, where you can look back and you can say, oh, 2 weeks ago, such and such posted this thing about their system. It's quite useful. We should go back and look at it. And if you're wondering why the name's so heavy, it's because I wanted engineers to have something kind of funny or silly they could say. So every time you did some work, you'd say, I did the thing, and then you know you posted it. Yeah. And a bonus, this came from our lead directly. He had a lot of people in other departments going, are your engineers actually doing any work day to day? And he'd just open DIDs and go, well, there's the last week of what half my team's done. So conversation over, which he was really proud of. Documentation, I think this is a challenging for pretty much everyone, and I've got nothing special, to be honest. No silver bullets. The best we came up with is we've hired what we've called a production engineer. So this is somebody embedded in the engineering department who's a non-technical person, and their role is documentation, communication. They support us through asking design questions, chasing up stuff where you're like, oh, was this supposed to, was this plant supposed to be painted yellow? Instead of me going asking a designer, I just say, production engineer, go ask this question, tell me when you know, and I'll fix what I need to fix. But other than that, yeah, documentation's still a problem. So if anyone's got any amazing solutions, please come and tell me. I'm very, very interested. Another challenge we had with this was prototyping. So due to all the systems being quite heavy on engineering and dependent on us providing the solutions, if new things were required, new tech, we couldn't really ask designers to just go ahead and prototype things because they'd forgotten how to use Blueprint. Those skills had atrophied. It had been 2 to 3 years since any of them had opened a Blueprint, which is great for us for shipping a current game, but if they're prototyping new products, it becomes a bit slower. And this was exacerbated by the fact that it requires code. Most of the scripting tools can be written in Blueprint, but we've set a strong rule that they should be written in code because there's a lot more usability and the ability to set meta tags, which I'll show you in a minute why we want meta tags. Education and debugging. So because this was all proprietary stuff, it's all in-house tech, and obviously we suck at documentation. We couldn't rely on Unreal's documentation, so we ended up struggling with information on things more complicated than just a DIDs post. So a couple of solutions we tried, in-house design talks, similar to this idea where you get a PowerPoint, you call everyone into a room and say, I'm going to try and teach you something. That worked a bit, huge time cost for the engineers involved. Creating scenario maps, this was one I ended up doing quite a bit. So a lot of the scripting tools are very self-contained, and you can build a map with 20 or so actors that showcases that one feature in isolation, and then you commit it to the build. And what this means is you've got live documentation. You can say to a designer, go look at that map. That'll show you exactly how to open a door and make it take 3 seconds. Just go look there. And then, obviously, as long as you keep those maps up to date, you've always got live documentation. Using a lot of debugging. So again, because these are our tools, we're able to just inject a lot of debugging behind the scenes, and design don't know we've done it necessarily. And showing designers how to use them was a huge time saver for us. Which was one of the big rules we set on R&Q, which was if designers ask you questions, try not to answer the question. Try to say, have you tried this style of debugging? Have you tried this specific debugging menu? Still doing okay for time, so here's some coding tricks. So how to make pure virtual work in Unreal. So out the box, Unreal doesn't allow pure virtual because they have to instantiate their CDOs. So you've got a macro, but that's just a runtime error, really. So the way I got this to work is with my game event states. These are all in their own little plugin. We've tried to modularize as much of the game as possible. You would make a base class, still all in the plugin. And importantly, the one you want people to derive from, you give it the API exposure. So everyone derives off that, really simple. And then the base class would have the functions in that you don't want them to skip. So in this case, you make a Blueprint native event, and importantly, you don't expose the base class. And if you do all that, anytime someone forgets to do one of your functions, they immediately get a linkage error like that. So you physically cannot get into the editor missing one of these functions. Not a perfect solution, it means you have to expose it to Blueprint as a native event, but we ended up using this in quite a few places to guarantee that functions weren't missed, especially for things like debugging, because we wanted to set a rule that every single game event would have debugging and have linked actors. We expanded that for Blueprint. So you might notice in the previous one, there's this meta tag required implementation. So we went into the engine, and you only have to change a couple of lines to make it so that as soon as you instantiate a new blueprint, or even open an existing blueprint, it will add those functions if they're not there and make it so you physically can't delete them. So by that standard, those three functions, which are the three functions the game event response cares the most about, are always guaranteed to be in a blueprint. It's up to the blueprinter if they actually fill in those functions correctly, but you can always guarantee those functions are there. Filter groups. So we had a sort of problem where, because there were so many game event responses, once we got further into development, you ended up having these huge lists, and it was hard to know, are these all appropriate for the correct calling location, things like that. So again, using meta tags, we just added the ability to say, you can specify a list of filter groups, and this is sort of like a type. And then when you declare one that you want to expose, you just set a list of allowed filter groups. Again, this was a handful of lines in the engine. Just go to the selection list part. And what this means is when you've got two lists, one with it and one without, there's a massive difference in number. So this means for things like actor attachment, for example. An objective probably doesn't want an actor attached to it. It's just a floating actor in the world with no physical manifestation. You don't want to attach it. So why even give that option to level design, basically? Just shrink it down as much as possible, and it gets most of it done for you. The reason we didn't do this with inheritance, because obviously you could do inheritance and you could pick the base type that you want, is we wanted some that could take multiple filter groups. So we had functional and character, and a thing that affects a character could most likely do functional, and we didn't want to create a convoluted hierarchy. It also means if we change our mind, which we did on a few, you've not broken anything. This is editor time selection. So they all have the same interface, all have the same functions. The designer can literally copy and paste one from another place onto this. It will still work. It's not a 100% stopgap, but it just says these are the list we expect should probably work for where you're trying to use it. Another good one, display priority. So I don't know if people have used this. This is quite a nice one in Unreal. Another meta tag, not used very often, lets you order your variables across hierarchies. So with the scripted sequence, I specifically wanted, during development, I was saying about iterative development and wanting incremental changes. I wanted to put a piece of text on to just say, appreciate if you didn't use this, it's going to take me a couple of months to really get this up to speed, but I don't want to do it as one big commit. By putting a higher, lower, I suppose, display priority, I can guarantee it's at the top. What this also meant was I wanted my scripted sequence stages to read in a very specific way. I wanted it to feel a bit like a while loop, and no matter how many different derivatives of this stage we made, I wanted the interface to always look basically the same. So it always starts with the exit condition, has the 3 game events, bit of debugging information, and then the data is always second. So by default in Unreal, the deeper into the child you go, that data is always first because it does it child to parent to grandparent when it's evaluating the data. Which is often nice, but not always. And yeah, display priorities let you get around that. It's a little fragile because obviously it's all number-based, so you can very easily make a mess. But as long as your hierarchies aren't too deep, you can usually control it. So, summary of what we did then. So this was what the designer asked for, and we provided all of it using current scripting tech. So we have a couple of KBEBs turning things on and off. We made a conditional actor. We had a game event which makes it explode. And then once we get to the trigger shape, we had a nice kbeb to turn it on and off, keep it active only when we need it, and we had a game event state ready to play the music for as long as the player's in the shape. And that is it. Any questions?